All right. Hello, everyone. In this session, we are going to learn about API design and development. So, here's the agenda, what we are going to learn about APIs today. So, firstly, we would be understanding what an API is. We will be understanding it with very simple analogy that would help you to understand API in more better way. Then we would answer this question, why are APIs needed in the first place? All right. And then there are many different ways to implement APIs. So REST API is one particular architectural style which we are going to look into, and we will look into rules and best practices for REST APIs. And then at the end of the session, we would be looking at how to design APIs for some sort of a learning management system like Udemy, Coursera, Scalar, etc. Right? So let's jump into a question. What's an API, right? So if you Google search it and if you find an formal definition, it would be looking something like this. It's an application programming interface, or API enables companies to open up their applications, data, and functionality to external third-party developers, business partners, and internal department within their companies. So I'm not going to read it beyond this point. This definition sounds very complex, right? So we are not getting any good understanding of what API means. So let's take a simple example from real life and try to see a similar example where API comes into picture. So let's say you want to eat some favorite dish of yours, a very delicious dish, and the recipe to cook that dish is very complex. There are a lot of steps involved, and even though if you perform all those steps, you cannot perfectly cook it. You might know this from your past experience, right? But you know that there is some restaurant which creates this dish perfectly for you. So what you are going to do, you would go to that restaurant, right? But would you be cooking that dish on your own when you go to that restaurant? No, right? So what you would do is, basically when you go there, you will ask waiter to prepare a dish for you. Then that waiter will go and ask some specialist cook to prepare that dish for you. Cook knows how to prepare that dish perfectly, so they will prepare a dish for you and then give it back to waiter, which in turn will give the dish back to you, right? So what has happened is here is you have not interacted with cook directly, and you have not cooked the dish on your own. So here waiter has become an intermediary who helped you to get that dish cooked for you, right? So that's an analogy you can make to understand what an API is. So over here, waiter behaved like an API. All right. So basically, if we want to understand API in software terms, then imagine that like you have an awesome piece of software with rich set of functionalities that you have made. Like you have worked very hard, you made it robust, reusable, so that other developers could also use it, right? But how would you make other developers to use this awesome piece of software that you built, right? Let's take an example. So you build a payment system. You want other businesses to use your payment system to make payments. So one of the examples could be when you check out from different e-commerce website, you want all those e-commerce websites to use your payment system, right? So, but before jumping into understanding API in terms of software, in this current example, your question that you might have is, why would someone need a payment system that you built, right? Why can't they create a payment system on their own? Just think about it. Like the payment system that you built, you might have kept and added a lot of efforts in there, and you worked very hard to make it robust, scalable, reliable, and you know in and out of how payment system work, right? So some another business who just wants to make payments they don't need to spend this much amount of time in building just a piece of system that would be used, right? So they want to focus on their business, which might be, let's say, e-commerce, right? So they want to focus on e-commerce. They don't want to spend time in building a payment system. So what they would do is they would ask some another system who is expert in making payments. They would use those payment systems to do so. So what happens is they wouldn't reinvent the wheel, and they wouldn't create a software system every time they have a new requirement. So let's say they want to send SMSs, they want to send emails. For every new system, they can't write those software systems from scratch. They have to the businesses have to reuse such a kind of an already existing systems. So how would this happen? How would you be able to sell your payment system to others, and how would other systems call your payment system to make those payments, right? And one of the probable scenarios that you might think is, let's say you have a database where you are storing all the transaction details and balance details and stuff like that. So if, let's say, some another business wants to use your payment system, you might give an access to code, you might give an access to your database, right? That might be a naive idea to think about, but that is not really how things happen. So take an example of IRCTC website, all right? Like IRCTC has like details about trains, passengers, you can do bookings and stuff like that. And there are even third-party software systems who can do the same things for you, like ixigo, MakeMyTrip, etc., right? So IRCTC wouldn't be giving access to their code and to their database systems directly to those third party. They wouldn't be doing that. It would be risky to do so, right? Anybody could manipulate any data in the system, right? So how to do it in a good way, in an ideal way, is using API. So what happens is client sends a request to do something like let's say make a train reservation or fetch some data, like bring all the train details, right? Fetch all the train details. And then the server, so in our example it would be IRCTC, they would receive this request, they perform all the tasks or fetch the data that is needed, and then send the response back to client. So in our example of train booking system, a third party software like, let's say, ixigo would send a request to IRCTC to book a train or to fetch the train details. IRCTC would do all those tasks and send the response back to the client, which would be ixigo in our case. In a case of a payment system that we were thinking, so the business, like e-commerce business who is using your payment system, they would make a request to they would make an API request to your payment system to do some transaction or fetch some transaction details. Your payment system will perform all the tasks that are necessary, fetch all the data that is necessary, create a response that is valid, and then send that response back to the business who is using your payment system, right? So what has happened here is client's request got fulfilled. Like the client, in the case of a train reservation, they got their tickets booked, they know the details about the trains. In the case of a payment system, they were able to make a payment, they were able to get the transaction details. So client's request got fulfilled, but they don't know how was that request actually fulfilled. So the implementation logic is hidden behind the API, right? So now think this entire API concept that we learned in software terms and have an analogy with the waiter too, with the example of eating a dish in a restaurant, right? So you are the client and cook is your server who knows how to make a dish, and waiter is the API. So you are making a request basically to cook. You are sending that request via a waiter to cook a delicious meal, and then behind the scenes, you don't know how the dish is cooked. Once it is cooked, waiter will bring back that dish for you. So I hope this analogy is helpful to you to understand what an API is, and the examples that we took for like train reservation systems or payment system also helped you to understand what an API is, right? So in a nutshell, what is happening is a system, let's say system A is communicating with system B. So system A is sending some request, system B is understanding that request, processing it and sending back the response, and eventually system A would be understanding that response, right? So basically these two systems are communicating with each other. So this communication cannot happen in a haphazard manner. There should be some structure for it, like, right? There should be some rules and regulations that both the systems should follow so that they can understand each other's requests and responses. And that's where protocols come into picture. And since API has a similar thing that two systems communicate with each other, we need protocol for APIs too. So some of the well-known API protocols are SOAP, RPC. So in RPC particularly, you can communicate via different messaging methods like JSON, XML. There is even a gRPC which uses protocol buffers, and there is a REST. So REST is not actually a protocol, I would say. It's an architectural style of how to build APIs. But REST is very popular, and it's almost a standard. Like almost most of the backend systems are developing APIs using this REST, and those are known as REST APIs, or you would have seen RESTful APIs. So for rest of the session, we are going to learn more about what are REST APIs. So yeah. Basically, to give you an introduction about REST API, so as we know that client and server communicates with each other, and that communication protocol is an HTTP 1.1, which is an application layer network protocol. So using HTTP 1.1, client would send a request to the server, and using the same HTTP 1.1, the server would send the response back to the client. Although like JSON is not mandatory as a communication message method, but still it's widely used because it's very simple to understand. And then like in the REST APIs, everything is resource based. So to give what I mean by resource based is, if you take an example of a train reservation system, the entities that you can think is like trains, passengers, reservations. So all the REST APIs would be based on these entities like trains, passengers, reservation. It won't be functional based like get trains and things like that. The third point would be more clear once we dive bit more deeper into REST APIs and look at different URI structures. All right. So next point is like the REST is a stateless protocol. So client needs to send all the information that it needs from server in the same request, and server will not remember any of the thing. Like for example, if client makes two requests, request 1 and request 2, in request 2 server should not know anything about request 1. So that's the basically ideal way to implement RESTful APIs. Then to improve performance, server might cache some already known responses. All right. So these are some of the points to know about REST APIs. So let's see the rules that must be followed for your API to be called as RESTful APIs. So the URI structure that should be formed for REST API should be resource based. So in this case, users is an entity. So the API structure that should be followed is like API v1 users. It should not be functional based like get users or something. So in a case where you want to get train details, in case of a train reservation system, your API should be API version like v1 and then trains, things like that. It should not be get trains or anything like that. That's the first rule. The second rule is it should be always plural, like it should be users, not user. It should be trains, passengers, reservations, things like that. The third thing is like there are several HTTP verbs like get, which means you want to get one or more resource, post, which means you want to create a new resource, put is like you want to update the entire resource, patch is like out of a resource you want to update some fields, and then delete is like delete resource. So when you are designing REST APIs, you have to design like two things. One is how would your you have to design how would your URI would look like, how would your API URI look like, then what would be the verb in front of it. Those verbs should make sense of what API is doing behind the scenes. So for example, if your API is giving you a list of resources, then it should be something like get API v1 users, something like this. It should not be any other verb because that would give a different meaning to your API. So if you use post API v1 users, that would have a totally different meaning. So let's say if you are creating an API where you are creating new users, then it makes sense to use post. But for getting new users, you should use get. Similarly, you can see like this examples where let's say you want to update a user, then the URL should not look like update users and should not be a post API because you are updating. Post is for creating new resource, put is for updating. So you should use put. Similarly, like if you want to delete users, you should use delete keyword, right? So these are some rules that should be followed. The another rule is like you should provide proper response codes. So what are response codes? So when server sends a response back to client, in a single number, it shows what happened with the response, like what happened with the processing. So let's say when you hit an API and if server responds 200, then that means that everything is okay and like you were able to successfully execute your API. If you get a 201, then basically it's again a success, but it is reserved for letting clients know that the resource that you want to create is created. So in case of a API like post API, you would use 201, and for others like get, update, things like that, you would use like 200 response code. Then there is 204, which means success, and there is no content in the response, like everything went okay, but server says that everything went okay, but I don't have anything to tell you. So that's it. Like this could be a case where you are deleting something maybe. So if you just want to delete, then server might say, okay, I deleted it. It will give you 204, which means you need to know that delete went successful, but it might not return you anything, right? So in general, 2XX. So these are three examples that I have shown. There might be many others. So in general, 2XX are the success response code. So your REST API was successfully executed. It shows that. Then there is 4XX, which means client as in whosoever is calling API made some mistake. Like for example, 400, it's for bad request, which means you didn't send complete details. Let's say for an example of making a payment, you didn't send an account number of whom to pay, or you didn't send an account number or you didn't say an amount field, how much to pay, right? So if you hit an API without amount to pay, the payment system that you build should return bad request. Then there is 401, which means like unauthorized request, like you call some API making a payment, but you don't have an authority to do that payment, right? You don't have proper access to execute an API, so you will get an 401. 404, like it's very popular, resource not found. So you're trying to call an API, but that API does not exist. So you will get a 404 there. 500, so these were all 4xx, which means client, caller made some mistake. Then there are 5xx, which means server, whosoever is processing your request made some problem. Like there is a popular one, 500, which means some problem happened inside the server. So let's say you build a payment system, but your payment system is unfortunately overloaded. It is not able to handle the lot many requests, and when you make yet another request, it might say it might not have enough memory to handle that request, so it will give you internal server error. So yeah, these are the response codes, and basically you should be giving proper response code. It should not be like the API response was successful and you gave a 400, like, right? Then client will not be able to understand properly what happened with the API. So these were the rules. Then there are certain good to have features also. So like filtering, sorting, pagination, proper response codes, error response in case of NPAIA, versioning, idempotency, documenting, securing, etc. Right? So let's understand them one by one. I will start with the ending. Like securing APIs is like everyone should not be allowed to execute your APIs. There should be proper access control, like authentication, which means you should be validating who is calling, and authorization means whosoever is calling is really allowed to do so, right? So you should be implementing proper authentication on authorization mechanisms. Documenting APIs clearly is like you should be creating proper documentation for your APIs to tell and provide it to your clients so that they can know in detail what exact API is doing. Then there is idempotency of APIs, which means let's say you made a payment, to make a payment you called an API, and after some time, let's say you didn't get a response, then you tried to make a payment second time. All right, then if you made two requests for a same payment, and if both of them succeeds, then you would have made payment twice. Your API should not be like that, and there should be some mechanism where you can bring an idempotency, which means irrespective of how many times you call an API for a payment for an identity, like payment ID, transaction ID or something, the payment should happen only once. So that is some good to have feature in your API, right? If you don't have such good features in your API, then you might not get users. Let's see others in more detail, like filtering. So you have many entities in your system. You have many parameters, but you want capability to filter the resources, right? So for example, you have an API here where you can get employees, right? So how would the API look like is like API v1 departments, department ID. So for this department you are asking for all the employees, right? So this department ID is called a path parameter because it's a parameter. It would be varying based on different calls, and as it is a part of URI path, so it's called path parameter. So let's say you have many employees in your system and you want some way to filter those employees. So let's say you want employees whose location is Bangalore and whose joining month and year is like July 2022, just for example. So you should be provide how your API would look like is, since you are fetching, it should be get, then API v1 departments, this all things would remain same. Then to provide a filter to filter by work location, you should be providing something like this. This is a query parameter because everything after this question mark is a query now. So you are saying that work location is Bangalore, then you have multiple queries. So you join them using AND sign. So you are saying that joining month is July and joining year is 2022. So basically you can change this query parameters. Let's say you want to find employees whose work location is Hyderabad, then you change this work location and it should be Hyderabad. You can send a mix and match of these query parameters. Let's say you want all the employees who joined in July 2022, then in that case you will drop this work location query parameters, right? And a general case, if you don't send any of the query parameters, you will get all the results. So such kind of filtering logic or filtering mechanism should be provided in your API, and things should be clearly documented, saying that what exact filters are available for your API. Then we have sorting, right? Like now let's say we have employees, but what if we want the employees who are sorted in descending order, right? So we need some sort of a sorting mechanism. So how would our URI look like? So firstly we want to tell them how to sort, like using which field we want to sort, and whether we want to sort them by like ascending or descending order, right? So this is an API URI. Again, it's a fetch request, so the verb would be get. Then our API path would look like this. Again, to remind you, this is a path parameter, and then we are giving some another query parameters which are specially reserved for sorting. So we are saying that sort by salary. So we are saying that we want to sort by salary, and then sort order is descending order. So if you want it by ascending order, then we would be providing ASC, right? So basically if we want to sort by something else, let's say name, then we would say that sort by name and things like that. So basically this query parameter, which is sort by, sort order, and what we need to send, whether we want to send ASC or the entire spelling of ascending, all these things should be clearly documented and provided to as a API documentation to your client, so that they can know how to do sorting. Again, we are just looking at how the design for an API, like how our API would look like. Behind the scenes, we would be using some sort of a framework like Spring Boot where we can implement this. So behind the scenes, we would get this into a variable telling like, hey, the request that came in wants to sort by this particular field. So so bear in mind that like we are just looking at a design for an API right now, and not the implementation. The real implementation will get all these details in some variables, and then will actually implement the logic to get the employees and then sort them out. All right. So one of the another feature that we might need to give is pagination. Like you have a lot many employees or lot many data, and if you send all that data, then your client might get overloaded. So just imagine how many reservations would have happened till now in IRCTC, right? There would be lot many reservations. If someone requests for all the reservations, then and if you by default send all the reservations till now, then a lot of memory would be required, right? So by default, you should never send all the records if you know that there is going to be a huge amount of records. So for that you need pagination basically. So basically a client should provide like what is the size of a single page and what number of page they want. So for example, if let's say you have a huge number of employees and you want basically let's say third page where each page size is 20, then it would look something like this. So you would add yet another query parameters, which would be like page size and page number. All right. So again, at the cost of repeating myself, this all the things like the query parameter, like page size, page number, all these things should be clearly documented and provided as it should be provided as API documentation. Basically, is that it? Like, do we need anything else apart from page size, page number? So turns out, let's say, how would basically client know that in a response which page they got and how many total pages are there? Should they be requesting another page or something like that? So imagine a scenario where you are showing all these employee details on a UI and you want to show some sort of a pagination, like first page, second page, third page, and things like that. So how would you know that? How would you know how many buttons to keep for the total number of pages? Like how many buttons to keep, right? And whether there is a next, basically next, if somebody clicks on next, whether there is a next page or not. How would you get all these details, right? So apart from changing your like API URI, you also need to change how a response is sent back from the server. So in the response, you should always include at least these 4 details, like what is the page number that's been asked? Is it a first page, second page, 100th page, or what? What is the size of a page based on which we are doing all this page calculation, total number of pages, and if you count, then what are the total number of records, right? So all these things should be provided. Your response should be manipulated, and all these things should be provided, right? So let's take an example where you are doing all the things, like you are doing filtering, sorting, pagination, all the things. So let's say you want list of employees who work at Bangalore, who joined in July 2022, and you want it to be sorted by salary in descending order, and you want the third page where page size is 5. All right, so how would your URI look? So we know that it's a GET request, so verb would be GET. This is a path, like URI path, standard URI path to get all the employees. Now we will add respective query parameters, like we wanted for Bangalore, so we added work location as Bangalore. We wanted joining month as July and joining year as 2022. Then we wanted a page of size 5 and page number as 3, and we wanted it to be sorted by salary in descending order. So this is how the URI look like. Then another thing is like sending proper response code, right? Like let's say if something is failing, let's say if client sent an invalid request, then they should be getting clear details about what went wrong and how they can fix that, right? So here it's shown that, let's say while creating a user or some sort of an entity like that, a surname field was required, but let's say client missed that. So you should provide a correct details, like the error is that, hey, they sent an invalid payload and then exactly inside the payload surname was missing, right? So, and also a proper response code of 400 should be sent along with this payload, right? Then there comes versioning of the API. So what we mean is that you made an API and you want to update the implementation of those APIs, right? So the updates could be breaking, like let's say adding a new mandatory field. So for example, let's take an example where IRCTC is implementing an API for reservation, and now they have made it compulsory to send a meal option. Is it a veg option, non-veg option, vegan option, or things like that, right? So let's say they are adding that new mandatory field, and if that field is added without versioning, then what would happen is all the client needs to update all this and add this new mandatory field all at once, right? So this is not possible for all the clients to do so, and what will happen eventually is that if you don't do versioning and add such kind of breaking changes, all the clients' requests would fail in production, right? So that's where you need versioning. So versioning allows you as an API developer to publish updates to your APIs. And while you have updated the API, your clients could chill, and then they can update to the newer API later point in time, right? So you could do a version basically update. So you have a version 1, version 2, version 3 of an API, and now you know that okay, version all the clients have at least updated to version 2. No one is using version 1. You can deprecate version 1 and you no longer need that. So something like that you can do using versioning. And here are some of the ways you can achieve this. So the first way you already saw in previous all the examples, we were having v1 as a prefix, like API v1. So v1 shows that it's a version 1, and then you can have version 2 with an updated logic over here, right? So you can even, so over here what we did is we took this version as a path parameter of some sort, whereas over here we are taking it as a query parameter. So you have two options, and the third option is also in the headers. Let's say you don't want to, so there is something called headers in HTTP 1.1. So when headers contains some sort of a metadata about the API request, and inside that header you can send the version information that hey, I'm particularly calling version 2 of the API or something like that. So the structure would look something like this: accept version 2.0. So behind the scenes, the API will understand, it will read the headers and know that okay, version 2 is requested, so we need to execute the logic of version 2. All right. Idempotent APIs we already discussed. Like if a same request is executed n times, then we should get same response, right? So get, put, and delete are idempotent naturally. So for a GET request does not change the state of the server. You are just fetching data from the server, right? So if you regardless if you execute a GET request for 1 time or 100 times, it would be idempotent. You will always get the same request. Same for put and delete operation. But your business should make like post and patch as an idempotent APIs, right? Learning how to implement idempotent APIs is out of scope for this session, and it needs entire discussion in itself. So I would leave it for another session, but bear in mind that idempotent APIs are really very important, especially in cases like you are designing payment system, right? You wouldn't want your clients to pay twice for a single thing, right? Yeah, so finally a time to see some examples of how RESTful APIs would look like for some LMS system. All right, so let's see what are the requirements that we have. So we need APIs for managing courses, let's say. So LMS is learning management system, where you can create courses and then students can buy those courses, right? And then they can ask queries on those courses, then you can respond to them, and stuff like that, right? So it's a learning management system that you are trying to build. You are trying to build RESTful APIs for learning management system. So yeah, over here we need APIs for managing courses. Like each course can have several sections, and each section can have several lessons. So for example, you have a course for backend engineering. Inside that backend engineering, you have a section called low-level design, and inside a low-level design section, you have a lesson called API design. So you have a structure like this. Now users can buy a course, like courses basically, and then for each lesson, for each particular lesson, students could ask a question and others could reply on those questions, right? So, and also for a course, a feedback could be given. So let's see how APIs would look like. So best way to think about designing is to know all the entities involved, and then design generally you would design like this 5, like post, get, put and delete, and 2 gets. I will explain you why 2 gets. But this 5 types of APIs for a given entity. So over here we have a course entity, and very first thing is we want to create course. So we will provide a post API. Remember, post was an HTTP word that was needed to create something, create a resource. And so over here we have like API v1 courses, remember plural, right? So this, if somebody hits API v1 courses with post, and there should be some request body also, which I have not shown, like what should be the structure of the course entity, that should also be needed. But over here I have only shown URI and the methods. So if somebody hits this API with that request body, then a new course would be created, right? Then let's say you want to know all the courses, so you will have a get API with all the courses, and again you should be providing some filters on top of that, right? Then you want a particular API where you know what is the ID of the course, and you want that particular course only. So you will design yet another API, which would be API v1 courses course ID, right? Then for put, it would be like you want to update a course, then there could be delete, you want to delete a course. So basically you would also have a patch. Let's say you want to just change particular field, like you want to change course title, then you would also provide a support for patch. It depends on the business, how many APIs you want, right? Then let's say you have for section, similar kind of APIs you have for section. Since a section comes under courses, so you will have courses, course ID. So inside this course ID you have all the sections. So you can create a section inside a course only, right? Remember, a section comes under course. So your API will look like this: courses, then a course ID. So what course are you talking about? And then sections. So if you want to create a new section, then you could create using this API. You want to know all the sections inside a given course, then you will provide this get API on top of that. If you see, there is only a difference of verb, the URI remains the same. Again, needless to say, you should be providing filters and all those sort of stuff over here. Then you want to know particular section, you want to fetch particular section, then you would add just section ID over here. So you can see that you are basically forming some sort of an hierarchy, and then you are reaching to that resource. So firstly, courses means all the courses, then you reach the resource, a single course, then you reached all the sections inside the course, then you reached a single section, right? So that's a get API to get a single section ID. Then you want to, let's say, update that section, so you have a put. You can similarly have a patch, but just know the difference. Put updates the entire entity, patch updates some fields out of that entity. Then there comes delete. You want to delete a section. Similar things you would also find for lessons. Now lessons comes under a section, so a single section can have multiple lessons. So you are saying that inside sections, what section ID are you talking about where you need to create lessons? So all these APIs would be having this kind of a structure. Now doubts. So let's say doubts you are creating at a course ID level, and maybe you could be even be creating at a lesson ID level. But over here I have, for simplicity, the doubts are stored at a course level, where maybe you can store for which lesson a doubt is there, right? So by doubt I mean a query, a question that someone might have for a lesson, right? So you can provide a API like this to create a new doubt. So when student creates any new question, it would be hitting this API to store that question, basically. Then there could be, like, you want to know all the doubts for a course, right? So useful query parameters would be for which lesson are you talking about. So for example, on your UI, when you are showing a course, lesson, and over here you want a Q&A tab, question and answers tab. So there, if you have provided a query param like this, then you could easily able to filter all the doubts for a given lesson. And then you could also have a ask by, where a user might be interested in knowing all the questions they ask for this lesson or for this course, something like that, right? So this asked by and lesson IDs are useful query params. Other filters also, based on what all other fields you have, you can provide. Then you want to get a specific doubt, let's say we have a doubt ID, then you could reach that doubt using this URI. You want to update a doubt, you want to delete a doubt, so you could use get, put, delete APIs. Then let's say doubts have responses, like somebody would answer those doubts, right? Then so what would happen is basically, since the responses are given to doubt, you would have a doubt ID in front of these responses. So basically, for creating a new response to a doubt, you would be saying which particular doubt you are talking about, right? So to create a new doubt, post API, to get all, to create a new response to a doubt, a post API. To get all the responses for a particular doubt, a get API would be there. Then to get a particular response, let's say you have a response ID, then you could get that using this get API. And then if you want to update the response, put API, and then delete a response, then delete API for a response, right? You might also need some sort of a user management sort of APIs that might be accessible to admins and some services who would be creating these users. So it's very straightforward, like users, post API, get API. To get a particular user, you would append a user ID at the end. To update a user, there would be a put API. There might be a patch API too. And then to delete a user, you would have delete. And in all the above things, there are two sort of deletes. A hard delete or a soft delete. So what do we mean by hard delete and a soft delete? So when somebody hits delete API, you have two choices. Whether you want to permanently delete your record from the database, that's a hard delete, which means there is a no trace of that particular entity. And what do we mean by soft delete is you are just setting some field saying that, hey, this is deleted, right? So that's a soft delete. And depending on your domain, you might choose soft or hard delete for all the scenarios, right? So yeah, there could be subscriptions, like users could buy subscriptions, which means they could buy some courses and stuff like that. So you would be storing those details at a user level. So you have an API to create a new subscription at a user level. So you are saying that for this user with this user ID, you are creating new subscription. So post API, get API to get all the subscriptions, get API to get a particular subscription, then to update a subscription and delete a subscription, right? Then there might be feedbacks. So feedbacks are at course level again. So you have APIs that look something like this. Again, it's very similar to many other APIs that we have seen. So yeah, that's it about the APIs. We have looked at what an API is, what's an analogy for an API, and we saw some rules for REST APIs and some good to have features for REST APIs, and we have even seen a API design for learning management system. So yeah, thank you. See you next time.